The PFAS nobody is testing for trifluoroacidic acid, TFA, shows up in beer, wine, fruit juice, tea, and organic plant-based drinks. It's in rainwater, surface water, and drinking water on every continent. It accounts for more than 90% of the total PFAS mass detected in some drinking water sources in Germany. And yet most standard PFAS testing programs don't capture it. That gap is starting to attract regulatory attention. Germany has moved to classify TFA as a reproductive toxicant, and the European Chemicals Agency is preparing a public consultation on PFAS restriction for spring 2026. The EU's updated Drinking Water Directive set a January 2026 compliance deadline, and in some member states, TFA concentrations alone are enough to push total PFAS levels above the threshold. Meanwhile, the EPA's evolving PFAS enforcement strategy in the U.S. remains largely focused on longer-chain compounds. Ultra-short-chain PFAS, like TFA, are barely in the frame. Dr. Cora Young, an environmental chemist at York University who has studied ultra-short-chain PFAS for more than 2 decades, and Craig Butt, a scientist at SciEx, recently explained why TFA is different, why it's so hard to measure, and what the research still can't answer. It's not just another PFAS. Most PFAS regulation targets longer-chain compounds, PFOA, PFOS, and their relatives, because those are the chemicals that have been studied longest and are understood best. TFA belongs to a different category entirely. There are mainly 2 ways ultra-short-chain PFAS are different from longer-chain PFAS. One is their chemical properties. They are much more water-soluble and behave a lot more like traditional acids like nitric acid. This also makes them very prevalent in bodies of water. Dr. Cora Young. The second difference is sources, and this is where TFA becomes genuinely difficult to manage. Longer-chain PFAS have relatively traceable origins: fluoropolymer manufacturing, firefighting foams, stain-resistant coatings. TFA comes from a much wider range of precursors, including refrigerant gases, certain pesticides, pharmaceuticals, and industrial fluorochemicals. Many of those precursors are still in active use. TFA is formed from compounds that have aryl CF3 groups as well as the so-called F gases, such as CFC replacements. Dr. Cora Young. Craig Butt put it plainly: the regulatory attention on longer-chain PFAS reflects what researchers know best, not what is necessarily most prevalent in the environment. As ultra-short-chain PFAS are newer and can come from a wider range of sources, we can expect to see broader regulations and increased monitoring for them. Craig Butt, SciEx, it's in everything, including your deionized water. Atmospheric transport is a big part of why TFA is so pervasive. Unlike longer-chain PFAS, which are primarily associated with point sources, military installations, industrial discharge, landfill runoff, TFA precursors have long atmospheric lifetimes. They travel. They deposit, they show up in irrigation water, in rain, and through plant uptake in food. No matter where your beverage originates, we expect to find TFA in it. And we do know that these chemicals are phytoaccumulative, meaning that they can make it into fruit and plants that go into beverages. Dr. Cora Young. Organic certification offers no protection here. TFA isn't an applied pesticide, it's in the water and the air. The organic label, Young noted, refers to what farmers intentionally apply. It says nothing about what arrives through rainfall or irrigation. A recent study found TFA in South Florida rainwater at levels that exceeded EPA health advisory limits for certain PFAS compounds carried in by air masses from northern states. That dynamic is consistent with global data. TFA is not a local contamination problem. It is a global atmospheric one. The contamination challenge extends into the laboratory itself. Even our deionized water is intermittently contaminated with TFA. Cora Young. Lab contamination is very difficult to address, particularly for TFA. It is important to test all consumables and solvents prior to use in your lab. In addition, it can be difficult to find a clean water sample to use for calibration sample preparation. Craig Butt, SciEx, the testing problem. Standard PFAS analytical methods were built for longer-chain compounds. TFA's physical and chemical properties, its small size, high polarity, and behavior like a conventional acid, make it behave differently in the lab, and standard solid-phase extraction techniques that filter out interfering matrix compounds also tend to pull out TFA. I think the methods that many labs are using, unfortunately, are not capturing these ultra-short-chain PFAS. Much of the interfering matrix that we are intentionally trying to exclude from our analysis has similar properties to these ultra-short chain PFAS. For example, we don't want nitrate interfering with our analysis, but it's hard to separate nitrate and TFA. Dr. Cora Young. Young and Butt have worked with SciEx to develop a method capable of analyzing PFAS from 2 carbons, TFA, up to 18 carbons, PFODA. But purpose-built methods for TFA are not yet standard in most compliance testing programs, which means EHS teams relying on routine PFAS panels are likely getting an incomplete picture of their actual exposure. Germany said reproductive toxicant. What does the science say? The German Federal Institute for Occupational Safety and the German Environment Agency have proposed classifying TFA as toxic to reproduction under Category 1B, a presumed human reproductive toxicant. The European Chemicals Agency is currently reviewing that classification. Young was direct about the limits of what toxicology can currently confirm, and equally direct about what concerns her. I am not a toxicologist, but what I can say about PFAS toxicity in general, including TFA, is that chronic toxicity is really what we've observed to be problematic. That is, exposure throughout our entire lifetime, not just a short term. The German study is the first evidence that there could be some chronic toxicity. Cora Young. The broader challenge is that TFA was long assumed to be benign because it doesn't bioaccumulate in animal tissue the way longer-chain PFAS do. That assumption is being revisited. The initial reluctance to consider ultra-short-chain PFAS in a regulatory framework is because they were assumed to be non-toxic, non-bioaccumulative. The evidence is starting to suggest that that might not be the case. Dr. Cora Young. In addition to issues mentioned above, we need to understand which tissues and organs are impacted by TFA exposure. This information is critical to helping us understand the overall toxicity of TFA to humans and the environment. Craig Butt, SciEx, a regulatory gap that's getting harder to ignore. The regulatory picture is moving, if unevenly. The EU's updated Drinking Water Directive required member states to comply with PFAS limits by January 12, 2026, and in parts of Europe, TFA concentrations alone already exceed the 0.5 mg total PFAS threshold. A 2024 study found TFA exceeded that limit in 79% of European surface water samples, with TFA accounting for more than 98% of total PFAS detected. The UK published its first national PFAS plan in February 2026, explicitly naming TFA research as a priority. The European Parliament has formally questioned the Commission about TFA's status as a planetary boundary threat. Only Denmark and Italy have set binding TFA limits in drinking water to date. In the US, PFAS enforcement is still focused on PFOA and PFOS, 2 compounds in a class of thousands. For EHS and compliance teams, the practical implication is this. If your PFAS monitoring program hasn't been reviewed against the specific analytical requirements for ultra-short-chain compounds, it probably isn't detecting TFA. That gap won't stay invisible as regulators on both sides of the Atlantic work toward more comprehensive coverage. I have been in this field for more than 20 years and have been interested in ultra-short chains for a long time. Over the past few years, interest in it has exploded, which is great, but there are still a lot of unanswered questions. Dr. Cora Young. What is answered? TFA is everywhere, it's accumulating, and the tools most organizations are using right now aren't built to find it. You've been listening to Sustainability Soundbites by Environment and Energy Leader. For partnership opportunities, please reach out to our team.